Okay, I hope it's recording. I hope. So in class, we did some sine graphing, cosine graphing, trigonometric graphing. I wanted to do an example on a video just to try to give you a super clear example. I hope this will be super clear. So here's one that we had slated to do in class. Whether we got to or not, I don't know. But it's got all the complexities we need. So let's talk about this graph. It's got y equals -6 sine of 1/4 times x minus pi over 2, all plus 4. So each of these things are a transformation or give us some indication as to what the graph looks like. So let's just mark these up. That's kind of the first step. We have -6 is the amplitude. So that negative means it's upside down, and that 6 means it's stretched vertically. This is the frequency. The frequency is equal to 1/4. Therefore, the period is equal to 2 pi divided by 1/4. So that equals 8 pi, right? 2 pi divided by 1/4. If you put a quarter will go into 2, 8 times. So that's 8 pi is the period. And then this negative pi over 2 means that it's shifted to the right, pi over 2. And the plus 4 means that it's up 4. Now, notice because both the period and the shift are in pi, your x-axis is going to be labeled in pi. Now, before we go on, let's just remind ourselves we have to deal with y equals sine x. So sine x starts at 0, 0. This is just a regular parent function. Starts at 0, 0, and winds up at 0, or winds up at pi 0, and winds up at 2 pi 0. And in between those, it goes up to 1, and then it goes down to -1. And we can kind of think of this as being cut into 4 pieces. So here's piece 1. Here's piece 2. Here's piece 3. And here's piece 4. And those 4 pieces are what we're going to be graphing. So that gives us a real clear look of kind of dividing sine graph into 4 pieces. Now these 4 pieces come from the 4 quadrants on the unit circle, but we'll be discussing that tomorrow. All right, so this actually comes from quadrant 1, this comes from quadrant 2, this comes from quadrant 3, this comes from quadrant 4 on the unit circle. All right, but it might be a little early to be discussing that right now. Okay, so I've set up a graph ready to go here. I've made it fairly large. I'm realizing that we have 8 pi for the period, and we have right pi over 2. So I'm labeling the x-axis. Each tick mark is 1/2 pi, right? So 1/2 pi, 1 pi, 3/2 pi, 2 pi, etc. But I also know I have to go 8 pi from this beginning point. So I'm going fairly far across. I'm going over to 10 pi. And I'm also looking at some things that are big. We have to have an amplitude of 6, and we're going up 4. So if we add 6 and 4, we have to go as high as 10. So here's my 10. And if we go down 6 and then up 4, an amplitude of 6 in the down direction and up 4, we wind up at -2. All right, so I'm going to start by trying to box in what will eventually, notice I'm moving around the page a lot. I'm going to try to box in what will eventually be equivalent to this box. All right, so in the horizontal direction, we have to go right 1/2 pi, and then we have to go right another 8 pi. All right, so here's my box here in this direction. There's that. And then from that pi over 2, I have to go all the way to 8 in pi over 2. So that's going to look like this. So that's going to be the beginning and end of my sine curve. Now, my amplitude, or actually, let's do this. Let's do the up 4. So the up 4, we know that the the x-axis basically is going to shift up 4 units. So we can come across here with that middle line. That's going to be equivalent to this middle line on that graph there. All right. And then our top, let me see if I can find another color, that'll be good. Something light. Okay. Our top is going to be 6 higher than that, 6 higher than that 4, so that's going to be at 10. And 6 lower than that 4, that's going to be at -2. And we know we have a negative sign graph. So sine graphs start in the middle, but negative ones go in the down direction. Now, the other thing you might want to do is just start to divide this thing in 4 pieces. Because we have these nice 4 sections here, we can divide this also in 4 pieces. Very visually we're doing this. Notice I'm not dealing with a whole lot of fractions. Let's see, the middle of half pi and 8½ pi is going to be 4½ pi. Right, the middle of 0 and 8 would be 4. So, but we're shifting to the right 1/2 pi from that. So we could make our middle here, right? And then halfway between each of those, halfway between the beginning and the middle is going to be here at 2½, and halfway between the beginning and the end is going to be at oh, is that right? It doesn't seem right. 2½. Yeah, 2½, and then 6½. Okay, good. So that's evenly broken up very nicely. And because we have a negative sine graph, we're going to be going, let me pick a nice bright color. Let's pick red. We're going to be starting in the middle. In the first quarter, instead of going up like we did here, we're going to go down instead. So see if I can get this back to here. So we're going to go from there to here. So we're going to have this shape, and then we're going to go back to the middle. We're going to just complete continuing on with our sine graph. All right, now remember, it doesn't stop here. It does continue. All right. And it doesn't stop here at the beginning either. It does continue. All right. And then if you have this set up nicely, you can actually label these super easily. Let's label the x-axes first. Put ordered pairs on these. Pi over 2. Well, here, let's do the y2. Pi over 2, 4. All right. And then 2½ pi. And let's do this as a let's not do this as a mixed number. That would be kind of weird. How about 5 pi over 2, -2. And then here we have 4½ pi, which would be, seems like 9 pi over 2, 4. And then we come up here, we're at 10 for our y value. And we're at 6½ pi, so that's 13 pi over 2. And then finally, we're at 8½ pi, so that's going to be 17 pi over 2. And at 4 again in our y direction. All right, so there is a very complete graph. You can totally, these boxes that I've highlighted and marked, you can totally use dashed lines for those and leave them on your graph. You can certainly use color the way I did if you like. But that gives you your rough general sketch of a sine graph. There is some detail involved there, obviously, more so than with a lot of the other functions. But you got to get the character in it, you got to get the amplitude in it. It's very helpful to actually show these shifts. All right, definitely get partial credit for that stuff. Okay, I hope that helps.